Greetings to everyone. This is Revathi, Assistant Professor, Department of Computer Science from Arignar College of Arts and Science, Krishnagiri. In this lecture, we are going to discuss about normalization in DBMS. This lecture part will cover what is normalization, why normalization is needed, what are the benefits and advantages of normalizing a table. Let's consider a single large table named student, which is used to store the information about the students in a comprehensive manner. A student table contains the attributes student ID, name, total credits, department name, building of the department, and room number of the department. Think we are adding the information to the table like ID number 1, Rahul, name Rahul, credit 10, department CSC, building number B1, room number 101, and so on. So clearly, if you observe, the information like department name and building in this values must be repeated multiple times in the same table, so which leads to the redundancy. So redundancy is nothing but which is the repetition of data or storing the same information in the multiple locations within the database. Problem occurs because I have taken the largest schema to store the information in the single table. So if we add HOD name, HOD room number to the same student table, the whole CSC department contains the HOD name and room number, which must be repeated and which is unnecessary and also leads to the redundancy. So redundancy is the root cause for various issues in the database. Let's discuss one. I said redundancy leads to data anomalies. So anomalies is nothing but anomaly compromises the data integrity and make the database inefficient. So why this anomalies occurs? Due to the lack of normalization, data redundancy, and improper usage of primary and foreign keys. So here redundancy leads to anomalies means which occur when the data has multiple copies and the updation in one place is not reflected in the other one, which leads to the data inconsistency, and also making it clear which data is correct, whether the updated one or else the old one. So there are three primary types of anomalies, whereas insertion anomaly, updation anomaly, deletion anomaly. So insertion anomaly. So when we try to insert a certain information, but we cannot do so without inserting an extra or a non-existent information. For example, suppose think adding a new department mechanical with the building name B1 and room number 120 before any students are enrolled in it. That means without any student admitted in that particular mechanical department, but we have to allotted the building and the room number to the particular department. So if you done so, you cannot only add department information to the student table because already it has the student name, ID and credits, which are all required attributes for that particular table. If you try to insert the null value for the student ID, here the student ID is a primary key which should not work when null values are entered in the primary key. So the problem rises here is storing the valid department information at least one student enrolls into that particular department. Next, updation anomaly. Updation in one record but not in all related records could lead to the incorrect data or data inconsistency. For example, suppose CS department shift their building from B1 to BC1 and room number 101 to 301. So in our large database, large student schema, this department information is duplicated for every student in CSC. That means this information must be repeated for in number of rows. Think if the row, if CSC has, think if you need to modify the building and room number to every record of CSC, if it contains the 100 rows, we need to update the 100 rows, otherwise which leads to the data inconsistent. Even if you are not updating in the single record, even if we miss a single record. Anomaly. Suppose we want to delete a certain information from the table. While we are doing so, we intentionally losing some unrelated or important information from the table, which leads to the loss of data. For example, suppose student ID 6, Akash credit 7 is the only student in the EC department. Think there is only one student in EC department whose student ID is 6, name is Akash, credit is 7. If you delete this record, student record, because he left from the college, the entire row will be deleted. So what is the problem occurs by deleting the try to delete the student record, the entire row is deleted. So this also deletes all the information about the EC department like building number, room number, because that information was stored only with that student record, not in the any other records. So, to the anomalies. Normalization. So normalization is nothing but it is a process of decomposing a large table into the smaller and manageable table. So to make them free from the insert, update and delete anomalies, and to save the space by reducing the redundant data. Already I have told you, when we are repeating the same kind of information or row of information in the same table, which consumes the more memory. So to overcome this anomalies, we are going to do the decomposition. So decomposition in the sense splitting the tables into the splitting the larger table into the multiple small tables. That means here we are going to split the student table into the two small tables, which is called student table and department table. Student table contains the information like student ID, name, total credits and department name. In the department table has the columns like department name, building and room number. So these tables are related to each other using a foreign key. So here in the department table, department name acts as the primary key. In student table, department name acts as the foreign key. So referring to the primary key in the department table. So using this department name, we can communicate or associate between this student table and department table. How decomposition solves anomalies? Solving insertion solves anomalies. Solving insertion anomaly. To insert a new department, for example mechanical B1 120, you simply insert the information directly into the department table. No need to insert null data into the department information independently. Solving updation anomaly. Updating the CS department building from B1 to C1 and room from 101 to 301, you only need to update one tuple in the department table instead of making updating the multiple tuples in the student table. This single update automatically applies to all the tables associated with the CSE, which ensures the data consistency. Solving deletion anomaly. If a student like Akash leaves, you simply delete the record from the table. The EC department information remains intact in the department table as it is the separate entity. So what all is, the department table is maintained separately so that even if you delete the Akash information from the student table, it won't affect the department information, EC department information in the department table. So definition of normalization. Normalization is the process of making a database table free from insert, update and delete anomalies, save space by reducing redundant or duplicate data. What are the benefits of normalization? Reduce redundancy, which means minimizes the duplicate data, which is minimizing the duplication of data. When we talk about the normalization, it is not ensured that normalization completely removes the redundancy. It removes the duplicate data, but somehow it ensures the redundancy. It won't completely remove the redundancy. Space saving. Less redundant data means less storage space. So when we are trying to reduce the multiple data entries in the different locations or different tuples, we are minimizing the data stored in multiple locations by splitting the table into the multiple table. Automatically the storage space will be reduced. Reduced anomalies. So eliminates or greatly reduces insertion, updation and deletion anomalies. Minimized null values. So when we split up the larger schema into the multiple tables, which avoids the unnecessary usage of null values when the information is not fully available. Simplified queries. So the smaller well-structured tables are easier to query when comparatively when it done with the bigger or larger schema. Simplified database structure. Looking at the multiple smaller well-defined tables makes the overall database schema easier to understand compared to one larger table with many attributes. So why this normalization is not always preferable in the sense, so this system store the vast amount of historical data and are primarily used for complex analytical queries often involving joining multiple tables. In such scenarios, renormalization, intentionally adding some redundancy, might be preferred to improve query performance. Having data in a larger table reduces the need for frequent table joins, which can computationally expensive for complex analytical queries. Important consideration and next steps. Decomposition difficulty. Finding the right decomposition is a crucial and sometimes complex process. It is essential to ensure lossless decomposition, meaning no data is lost during the division of table. So normalization involves in multiple levels of normal form such as first normal form, second normal form, third normal form, Boyce-Codd normal form, fourth normal form, fifth normal form and sixth normal form. Each normal form addresses specific type of redundancy and dependencies. Thank you.